Assalamu alaikum. Our topic is addition and subtraction of algebraic fractions, and this is exercise 6b, D2, 7th edition, chapter 6. This is on page number 170. In the previous class, we were discussing how to solve algebraic fractions. We were basically simplifying them, and in this video, the topic is basically addition and subtraction of algebraic fractions, and we know that we can add or subtract fractions by the method of LCM. So this is not a new method, and we will be applying the same method in these sort of questions as well. These questions are looking very lengthy and the working is quite extensive, but if you are following the right steps, if you are making sure that you are doing the steps correctly, and you just have to follow the basics, you just have to practice them well, and inshallah there will be very less chance of error. So we will start with some questions of exercise 6b. Exercise 6b has a lot of questions of different varieties, but we will not be covering all those questions. We will be covering some questions, and inshallah after solving these questions and watching this video, you will be able to solve the other questions as well. So algebraic fractions, we know that fractions, we have fractions, there are two components in a fraction. The first thing is the numerator. The upper part is called the numerator, and the number which is below the line is called the denominator. So we have a numerator and a denominator whenever a whenever a fraction is given to us. So these are algebraic fractions. So these fractions will not have only numbers, they will be having variables as well. So algebraic fractions also have a numerator and a denominator. So we have 4 questions in this video. This is question number 1 part A, and this is question number 1 part F. This is question number 2 part F, and this is question number 2 part H. The first question, we have 7 upon 6a plus 4 upon 9a, and we have two fractions and we have to add these two fractions, and in order to add a fraction we have to make the denominator same first. So the denominator is basically 6a and 9a, so these two are different denominators, we have to make them same. So we can see that we can make 6 and 9 a common number, and 18 is that number which is the common multiple of 6 and 9. 18 comes in the table of 6 and 18 also comes in the table of 9. So I am going to make the denominator as 18a. In order to make it 18a, I have to multiply it with 3, and if something is multiplied with the denominator, we have to multiply it with the numerator as well, because this is a law of mathematics. And here it is 9a. In order to make it 18a, I have to multiply it with 2. So if I'm multiplying 2 with the denominator, I have to multiply 2 with the numerator as well. So 7 times 3, 7 multiplied by 3 is 21, and 3 multiplied by 6a will be 18a, plus 4 times 2 is 8, and 9a multiplied by 2 will be 18a. So after multiplying it with the same with the number, I have successfully made the denominator same. This is also 18a, this is also 18a. So when the denominators are same, I just have to write them once. So I will draw a line like this because this is a fraction. I am taking LCM now. So 18a and 18a, when the denominators are same, I have to write the denominator only one time. So I am writing 18a, and then I have to see what is in the numerator. There is 21 on this side and there is 8 on this side, and they are being added. So 21 plus 8 gives me 29. So 29 upon 18a. Since this cannot be further simplified, so this will be the answer of this part, 29 upon 18a. In part number F, this is basically part number F. In part number F, we have 3 fractions, and the first fraction is p upon 3, p plus 3 upon 2z. This is the first fraction. And the second one is plus p minus 1 upon 6z. The third one is minus 2p plus 1 upon 3z. So these are the 3 fractions, and I have to add the first two and subtract the last one. So in order to add them or subtract them, I have to make the denominator same. So how can I make the denominator same? There is 2z over here, there is 6z over here, and there is 3z in the last one. So I have to make them same. In order to make them same, I have to multiply them with some number. So I can see that 2, 6 and 3, 6 is basically a multiple of 2 and 3. So I can make 2, 6 or 3, 6. So how? I will multiply it with 3. When I will multiply 2z with 3, and so I need to multiply that with the numerator as well. So I will multiply it with the numerator. 3 multiplied by 2z will be 6z, and when I will multiply this 3, I have to see that it is a bracket. There are two terms inside the bracket, so it is just like the expansion. Expansion, you need to remove the bracket. So in order to remove the brackets, you see if there is any number outside the bracket, you multiply that thing with the every term that is inside the bracket. So this will be 3p, and 3p plus 1 will be 3. Similarly here it will also be 3 multiplied by p will be 3p, and then plus 3 times 3 will be 9. So this will be 3p plus 9 upon 6z, then a positive sign in between, then p minus 1 upon 6z, then a negative sign, and since I have to make 3z 6z, so I have to multiply it with 2. Since I am multiplying the denominator with the 2, so I have to multiply the numerator with the 2 as well. So this will be 2 bracket 2p plus 1 upon 6z. There is a negative sign outside the bracket, so we have to be careful about this sign. Since the brackets are same, since the denominators are same, so I will write the denominator only one time, that is 6z, and all the things in the numerator will be as it is, because all the denominators are 6z same. So this will be 3p plus 9, this will be p plus 1, and here there is a negative sign and I have to remove this bracket as well. So I will multiply minus 2 with both the terms. So minus 2 multiplied by 2p will be minus 4p, and minus 2 multiplied by plus 1 will be minus 2, and whole divided by 6z. Now I have to simplify it more. I can see that there are some terms which have p, so these are like terms. So variables on one side, numbers on the other side. I can see that this is a 3p, this is 1p, so 3p plus 1p will be 4p, and then there is a negative 4p, and 9 and minus 1, 9 minus 1 will be plus 8, and plus 8 minus 2 will be plus 6, and I can see that plus 4p and minus 4p can be cancelled out because they are same. The only difference is of the sign, so they will be cancelled out, and the only remaining thing will be 6 upon 6z, and I know that 6 and 6 can be cancelled out, so the final answer of this part will be 1 upon z. Since I cannot further simplify it, so this is the final answer. So this was a question. These two questions were the strategy was the same because I have to make the denominator same, and I did that by multiplying it with some number. So these two parts were same. The third part, in the third part again, I have to add two fractions. This is question number 2, part F. 3 upon k square minus 1 plus 2 upon k minus 1, and we have two fractions and we have to add them, and again the strategy is the same. We have to make the denominator same, but I cannot see the denominator making same. I cannot use a number to multiply it because this is k square minus 1 and this is k minus 1, and I cannot multiply it with the square term. So what should I do? I should think about some other strategies. And we know that in the previous video, we solved some questions and we simplified the denominator by the trick of factorization. So we can apply the factorization technique over here. We can make factors, we can introduce the strategies of factorization, that is the common strategy, the identity. We can use the identity to make it simplified. So I will be using them when I will be thinking about them. And I can see that this k minus 1 cannot be factorized furthermore because it is in the simplest form. But this k square minus 1, this thing is grabbing my attention. I can see that I can do something over here, and if I can use an identity, I can transform it into the third identity, that is k square minus 1 whole square. Like this, I can write it like this. And since I know that this is the third identity, the square is also here, the square is also here, so I can expand it, I can factorize it, I can factorize it by writing k plus 1 and k minus 1 like this. So I can factorize this denominator by applying identity. So I have applied the identity. The identity is the third one, that is the a square minus b square identity, which is equals to one time there is a positive sign in between the two terms, and the next time there is a negative sign. So I can write it like this, k plus 1 and k minus 1, and the remaining will be 2 upon k minus 1. And now I can see some similarities in the denominator. There is a k minus 1 bracket over here and there is a k minus 1 bracket over here. The only thing which is extra over here is k plus 1. So what will I do? I will just multiply k plus 1 with the denominator and the numerator as well in order to make the denominator same. When I will do that, I will get the denominators same, k plus 1, k minus 1, k plus 1, k minus 1 on both sides. So since the brackets are since the denominators are same, so I will just write them once, k plus 1, k minus 1, and then in the numerator I will just write 3 over here because I didn't multiply anything on this, and on this side I have multiplied with k plus 1. So I will write a 2 and then inside the bracket I will write k plus 1, and I just need to simplify it now. This is 3 and this plus 2 will be multiplied with k to get plus 2k, and this plus 2 will be multiplied with 1 to get plus 2, and I know that 3 plus 2 is 5, so this will be 5 plus 2k upon k plus 1 and k minus 1, which I cannot do further simplification, so this will be the answer of this part. So you can clearly see that in order to make the denominator same, you can either multiply them with the same number. You can multiply it with a different number, or you can also use the factorization techniques in order to further simplify your your denominator, and then identify how to make them same by multiplying it with some number. So this is basically the second strategy. The third question, which is question number 2, part H. In this question, we have 2 upon n minus 2 plus 3 upon n minus 2 whole square. So again, you guys will be thinking of an identity, but instead of applying identity, I can break this bracket into 2. I can use this concept. I know that 2 square means 2 multiplied by 2. So n minus 2 whole square means n minus 2 bracket n minus 2. Because this is 2, so I have written this bracket 2 times. And since now I can see that there is only one n minus 2 on this side and two n minus 2 on this side, so the thing extra is n minus 2. So I have just multiplied n minus 2 with the denominator and the numerator in order to balance this fraction. And now you can see that the n minus 2, n minus 2, n minus 2, n minus 2, both the denominators are now exactly same. So I will just write them once, n minus 2, n minus 2, and then inside the bracket I have to write 2 and then n minus 2. So I will write n minus 2 and then bracket close minus 3. And now I just have to multiply them. In order to multiply them, 2 multiplied by n will be 2n, and 2 multiplied by minus 2 will be minus 4. So this will be minus 4, and this will be minus 3, and upon n minus 2. And just need some simplification. I know that this is 2n and this is basically minus 4. So this is basically plus 3. So this will be plus. So 2n minus 4 plus 3 means minus 4 plus 3 is minus 1. So 2n minus 1 upon n minus 2. N minus 2, you can also write this again in the bracket form. 2n minus 1 will be as it is. And upon this will be, you can also written it like n minus 2 whole square. So both are same. Both answers are acceptable. So this is basically the final answer because I cannot do further simplification. You don't need to expand it using identity. That will further complicate your question. This is the simplified form and you will leave your answer over here. So addition and subtraction of algebraic fractions, quite a tricky thing, a hectic thing because there are a number of steps, but it is easy to understand because you just have to stick to your basics. You just have to stick to the factorization techniques. The motto, the aim is the same. The target is the denominators. You have to make them same. And once you have made them same, then you know how to solve them. But in order to make them same, you just need to identify some numbers which can be used to multiply them or the factorization technique, or you can use some more techniques which we will discuss in the later videos.